Do you know how to transpose a matrix? If your answer is no, then this video is for you. So hi guys, I Aziz welcome you to CoedMaster, and in this video I am going to talk about how to transpose a matrix. Please watch this video till the end. So let's get started. Alright, let's begin this video with this problem. And the problem is given as we are given a matrix and our task is to find transpose of this matrix. Now the question over here is, what does it mean by transpose? Well, transpose simply means to convert rows to columns and columns to rows. As you can see here that this matrix row has two elements 1 and 2 and 4 and 5. After converting rows to columns, it becomes 1 and 2 and 4 and 5. So this is what the transpose means. Now you understood what does it mean by transpose. So let's understand this problem with few examples. Let's see this first example. Here the matrix is given as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And this matrix is n cross n. This means count of rows is exactly equal to count of columns. And after transposing this matrix, the row becomes columns and columns becomes rows. You can see here 1, 2, 3, 4 is row. Now it becomes column. 1, 2, 3, 4. 5, 6, 7, 8 was row. Now it becomes 5, 6, 7, 8 row. 9, 10, 11, 12 was row before and after it becomes column. So on and so forth. Let's see the next example. Here the matrix is given as 1, 1, 2, 2. And after transposing it becomes 1, 2 and 1, 2. So guys, I hope now you understand this problem really well. So this is the right time to move ahead to the next segment of this video. And in this segment, we observe the problem and try to find out all the things that are hidden in this problem. So on the left side, you can see that this is a given matrix. And on the right side, you can see that this is the transformed matrix. Now here, if you look at this matrix carefully, you are going to observe three things majorly. First thing is the diagonal, second thing is the upper diagonal element, and third thing is the lower diagonal element. Okay. Now here, if you look at this matrix carefully, you will see that in both the matrix, the diagonal elements remain same, exactly same. There is no change at all in diagonal elements, isn't it? Now talking about the upper diagonal elements. So in this matrix, upper diagonal elements are 2, 3, 4, 7, 8 and 12. And the position of these elements are like for 3 it is 0, 2. Means row is 0 and column is 2. And the location of element 4 is 0, 3. This means 0 row and third column. And the location of 8 is first row and third column. And if you see the transpose of this matrix, the location of these elements becomes, in case of 4, from location 0 to 3, it moves to location 3, 0. And in case of 3, 3 moves from 0 to location 2, 2, 0 location. And in case of 8, it moves from location 1, 3 to 3, 1 location. So this is about the upper diagonal elements. Now let's have a look at the below diagonal elements. In below diagonal elements, we have 13, 4, 10, 15, 5 and so on and so forth. So if we just look at this element 13, the location of this 13 is 3, 0. Means third row and 0th column. Now after transpose, the location of this 13 becomes 0, 3. So do you see guys what is happening over here? All the locations are swapping with opposite location, right? Means 0, 3 swapped with 3, 0, 0, 2 swapped with 2, 0, 1, 3 swapped with 3, 1. So after this observation, we understood two things. First of all, we do not have to touch diagonal. And second thing is we only have to work on the above side of the diagonal. That's it. And the reason is simple, because if you see this element 4, the location of 4 is 0, 3 and the location of 13 is 3, 0. So as you can see in transpose, both the elements are swapped, right? This is really cool. And if you look at the element 3, the location of 3 is 0, 2. And you can see that 3 gets swapped with element 9. Okay? These both elements are swapped with each other. Now 9 comes here and 3 goes here. So this is what we learned from this observation. So our approach would be, first we have to run a loop for first row and second row and third row. Okay, because these are the elements that appears above the diagonal. Okay, and for each row we have to run a loop for each columns, right? So for example, in case of 3, the location of 3 is 0, 2. It gets swapped with 2, 0. And in case of 4, the location is 0, 3. It gets swapped with 3, 0. So this means we need 2 loops. One loop is for rows and second loop is for columns. So this is how we get the location of any element by accessing the rows and column. This is it. So we finally got the approach. Now let's move ahead and see the implementation of this approach. So on the left side we have a function transpose matrix, and this function is taking matrix as input. In first statement we are simply getting the length of matrix, and as I said that this matrix has n cross n size. This means count of rows is exactly equal to count of columns. So we can safely use length of the matrix as rows and columns. And then we are running a loop, first loop from 0 to less than n to access all the columns, right? And inside this loop we are again running a loop from I plus 1 till less than n. So for example, if I becomes 0, j becomes 1. And if I becomes 1, then j becomes 2. And if I becomes 2, then j becomes 3. Okay. Now inside this inner loop, we have simply written swap logic. So first we are storing the value of matrix ij into temporary variable, and then we are storing value of matrix ji to matrix I of j. And then we are simply storing value of temporary back to the matrix of ji. So this is the simple swap logic. You already know about it. So now let's quickly run this code and see how it works. So in first iteration the value of I becomes 0, and then in this iteration the inner loop begins. So first the value of inner loop start from j equal to 1 because we are doing here I plus 1. So in first iteration we are swiping 0 1 to 1 0. In next iteration the value of j becomes 2 and we are swiping 0 2 to 2 0, and similarly 0 3 to 3 0. Okay. So first iteration is done, this means first row is traversed and we are done with first row. Now it's time to move to next iteration to consider second row. So now I becomes 1, and in this iteration the value of j starts with 2. So the location 1 2 gets swapped with 2 1. In next iteration value of j becomes 3 and 1 3 gets swapped with 3 1. Okay. So in this iteration we have swapped these 2 elements, and in previous iteration we have swapped these 3 elements. Okay. Now only one element is left. So now the value of I becomes 2. In this iteration the value of j begins with 3, and this time we are swapping position 2 3 to 3 2. So this means we are considering this element 12. Okay. So after all of these loop gets completed, we get the transpose matrix as this: 1 5 9 3 13, 1 5 9 13, 2 6 10 14, 3 7 11 15, 4 8 12 16. And you can see this. And you can see here that diagonals are exactly same as before, and only the upper diagonal elements are swapped with below diagonal elements. Okay, so far so clear. So guys, I hope you understood this function, how it works and how all iterations are working and how we are swapping upper diagonal elements with lower diagonals element. So let's move on to the next part of this segment, that is time and space complexity. If you look at this implementation, it becomes very critical to say that how many times this loop is running. So whenever we encounter this type of cases, we simply use our best friend, that is big O. So when we are not sure about how many iterations are there, we can simply say the upper bound of the algorithm. And in this case for each iteration of outer loop, the inner loop runs maximum we can say n times. So we could say that the time complexity of this function is going to be big of n square. Correct? And what about space complexity? It simply remains theta 1 because we are not using any extra space. So overall, this function took big of n square time and theta 1 constant space to solve this problem. So I hope guys by now you understood that how to transpose a matrix. And if you have learned something valuable from this video, then hit the like button to make YouTube algorithm happy, and subscribe to this channel. And also do not forget to press the bell icon so my friend you never miss any upcoming new videos. So this is all from my side. Thanks for watching. See you in the next video.